Yes, moving towards next question. In which of the following compounds nitrogen exhibits highest oxidation state? See, the first one is hydrojoic acid. I think you all know it, NH3. So the first one is not hydrojoic acid, sorry. The first one is ammonia, NH3. We all know in ammonia nitrogen is in -3 oxidation state, and the next one is N3H, hydrojoic acid, N3H. And in the theory video I explained that in hydrojoic acid nitrogen is in -1/3 state, -1/3. Okay, now the oxidation state of nitrogen in N3H is -1/3. Why? How? See, hydrogen will lose one electron, okay, and that electron has to be shared by three nitrogens. So if one electron shared by 3 nitrogens, then each nitrogen gets how much? 1/3. So each nitrogen will get 1/3 part of that electron, so -1/3, and this is hydroxyl amine. I will give you the structure, NOH, H, H. Now the oxidation state of nitrogen will be -1, -1, +1, right? -1 for this bond, nitrogen will get -1, -1, +1. So -2 +1, so -1. So here nitrogen is in -1 state, here -3 state, and here -1/3 state, and this is hydrazine, N2H4, N2H4. Here nitrogen is in -1, -2, and for nitrogen bond nothing, na? So this nitrogen is -2 state. Both nitrogens will be in -2 state. So in which of the following compounds nitrogen exhibits highest oxidation number? See, the possible, now simply we can answer this like, the valence shell configuration of nitrogen is 2s2, 2s2, 2p3. So okay, if the nitrogen is getting electron, that means if the nitrogen is gaining electron, how many electrons it can gain? 3, na? So -3, -2, -1, 0, +1, +2, +3, +4, +5. That means if the nitrogen wants to gain electron, maximum it can gain 3 electrons, because by gaining 3 electrons, if you add 3 electrons, it will become 2s2, 2p6. So it will get octet configuration. So maximum it can gain 3 electrons, means the most reduced state. So the minimum, I can say minimum oxidation state. Minimum oxidation state will be -3. And if the nitrogen wants to lose electron, how many it can lose? 5, na? Because in the outermost shell there is 5 electrons. So the maximum oxidation state can be +5, minimum can be -3. Okay. So in all these, so -3, -1, -3 to -1, -3 to -1, oxidation number increased. -1 to 0, in between there is one more we can find here, that is -1/3. So among these four options, the highest oxidation state you can find in -1/3, that is N3H. Okay, yes. Next, in acidic medium, H2O2 changes Cr2O7 2- to CrO5. Okay. So H2O2, you know, it can act as both oxidizing agent and reducing agent. Okay, H2O2 changes Cr2O7 2-, dichromate anion 2 CrO5. Okay. Now which has 2 OO bonds. Then oxidation state of chromium in CrO5. See, it's this compound I have discussed in the separate video where I explained the special oxidation numbers, so special compounds. Okay, there I explained. So this compound is an example having peroxy bonds, and the structure will be like this. I explained it is having butterfly like structure because of the presence of two peroxy linkages. Now, so the oxidation state of central atom comes out to be +1, +2, +3, +4, +5, +6. So it's +6. Okay? Yes. So it is +6, the maximum oxidation state of chromium. Oxidation number of sulfur in S8 molecule, you call S8, you call P4, you call N2, O2. See, when there is group of similar atoms, when there is same kind of atoms in a group like S8, P4, it is element, na? Elemental form. So when an atom is in elemental form, its oxidation number is going to be 0. Yes. Moving towards next question, 56. Oxidation state of nitrogen in N3H. We already completed this one. So -1/3. Oxidation state of nitrogen, na? Yes. What is the oxidation state of hydrogen here? Not only here, in most of the compounds, except hydrides, hydrogen will be in +1 state. Okay. So N3H is a famous compound. What I am trying to explain is, N3H is a famous compound in which nitrogen will be in -1/3 state. That is famous. Our brain becomes familiar with this. But in the exam paper, there is a chance for you to be asked, like you may be asked to give the oxidation state of hydrogen. It's very simple. Hydrogen will be in +1 state. +1 state, but this can be a trap, na? By just looking at this N3H molecule, you may by mistake you look for this -1/3. So carefully read the question and find out for which atom you been asked to find out the oxidation number. Okay? Yes. Oxidation number of carbon in CH2O. CH2O. This is formaldehyde. +1, +2, -1, -2, 0. So simple, huh? Yes. Next, oxidation number and valency of oxygen in OF2. OF2. See, oxidation number is +1, +2. I explained so many times, and valency is 2, na? Because 2 covalent bonds. So oxidation number is +2 and covalency is 2. Yes. In which of the following the oxidation state of chlorine is +5? +5. This one we did several times. HClO3 1 plus X plus 3 into -2 is equal to 0. 1 plus X minus 6 is equal to 0. X minus 5 is equal to 0. X is equal to +5. Here, chlorine is in +5 oxidation state. Now, all elements commonly exhibit an oxidation state of, see, element, just now previously in one of the previous questions I told you, when an element is present or when there is any atom in elemental form, oxidation state is 0. The maximum oxidation state that fluorine exhibits, fluorine can maximum exhibit 0. That means, see, fluorine, the most electronegative element in the entire periodic table. In the entire periodic table, fluorine is most electronegative. It means what? It means what? When fluorine bonds with any atom, fluorine will be in the state of gaining electron. Fluorine will grab electron. Okay, whether partially or fully. So if you take a compound like HF, or if you take any bond like OF or HF, see, here fluorine is bonded with hydrogen, which is obviously less electronegative. Hydrogen is the less electronegative. So when fluorine bonded to hydrogen, this bond almost goes to fluorine. So fluorine will be in -1 state, hydrogen will be in +1 state. That's okay, you can guess. But do remember, fluorine is the most electronegative element. It is electronegative than oxygen also. So when generally oxygen is more electronegative atom. It will be in -1 state, it will be in -2 state. But oxygen, when bonded to fluorine, oxygen will be in the state of losing electrons. So for this bond, oxygen will get +1, +2. I explained so many times. So fluorine will be in -1 state. So what is important here is the maximum oxidation state for fluorine will be, you will find in elemental form, that is the 0 state. That is the maximum oxidation state. That means you can't find fluorine in positive state, like fluorine in +1 state, fluorine in +2 state. You can't find like that. Okay? Yes. The minimum oxidation state that nitrogen exhibits, -3. Because when nitrogen starts gaining electron, the maximum, how many electrons it can gain? 3. Because by gaining 3 electron, nitrogen octet will be completed. By gaining 3 electron, the nitrogen octet will be completed. So -3 will be the minimum oxidation state and +5 will be the maximum oxidation state. Yes. In the conversion of K2Cr2O7 to K2CrO4, the oxidation number of following changes? None. Oxidation number of nothing changes. See, I explained with the structures in one of the previous question. In K2Cr2O7, let us say potassium dichromate. Here oxidation state is +6, and I will change the color as yellow. K2CrO4, chromate. Whether it is chromate or dichromate, chromium will be in same oxidation state. And you know very well about potassium. Potassium will be in always +1 state, and oxygen will be in -2 state. In this conversion, the oxidation number of any species is not going to change. Yes, so none. The oxidation number of nitrogen in HN3. See how many times you are getting this question. By mistake, I think. So -1/3. Yes. In which of the following compounds oxygen exhibits oxidation state of +2? Oh. So many times we are getting this oxidation number of OF2. Okay. So that much of important it is. Okay. OF2. The oxidation number of sulfur in S8, S2F2 and H2S. I will take S8, S2F2, H2S. See, sulfur and oxygen belongs to same family. Just like O2F2, there is S2F2. So in O2F2, oxygen will be in +1 state, then sulfur will be in +1 state here. It is elemental form, sulfur in 0 state. Here it is in -2 state, because compared to hydrogen, sulfur will be more electronegative if you take. Then 0 +1 -2. 0 +1 -2. Okay? Yes. Next, in the conversion of CrO4 to Cr2O7, just no change. Here it is chromate. Chromium will be in +6 state. It is dichromate. Chromium will be in +6 state. Remains unchanged. Okay. So now you got a different kind of question, matching. List 1, list 2, you have to match. Yes. Nitrite ion. Nitrite is NO2 minus. Okay? Yes. Hydroxyl amine. Hydroxyl amine means NH2OH. Nitrate ion. NO3 minus. Nitrous oxide. Laughing gas. Laughing gas. Don't laugh. Laughing gas. And nitrogen. Okay? Now match it. Now nitrogen in elemental form, for C it is first option. Okay? For C it is first option. You are having C, for C as first option, not option. For C, what is matching? The first one in the list 2 is matching. So you are having only fourth option like that. Okay, you got the answer anyway. First match all of them. See, nitrous acid, nitrogen will be in +1 state. That means for B it is 2. In nitrate anion, nitrogen will be in +5 state. Here nitrate anion, nitrogen will be in +5 state. So that means for D it is 3. Obviously for D it is 3. In hydroxyl amine, just previously I explained, OHHH, nitrogen +1, -1, so -2 +1, that means -1. So nitrogen will be in minus, that means -1, there is no -1 option, no problem. For A, +3 is for which one? +3 is for which one? +3, +1 nitrate. NO2 minus. Here nitrogen is in +3 state. Let us say X plus 2 into 2 negative is equal to the charge present on the species, -1. X minus 4 is equal to -1. X comes out to be +3. So for it is here nitrogen is in +3. That means for +3, what is the 5? Yes. So all are matched. That means the fourth option is the correct option. For A it is +3. +3 means the 5. Fourth option. Next, oleum. See, the oxidation number of sulfur in. See, oleum is actually H2SO4. Actually, it is the sulfuric acid. When you pass sulfuric acid, when you pass sulfur trioxide gas, into the sulfuric acid liquid, you will get this solution called oleum, H2S2O7. So the point is, here in the sulfuric acid, the sulfur is in +6 state. In sulfur trioxide also sulfur is in +6 state. It means in the oleum, both the sulfurs are in +6 state. No doubt about it. Question number 69. Now question number 70. Phosphorus exhibits highest oxidation state in. Okay. So this here phosphorus will be in -3 state. Phosphate, in phosphate, calcium phosphate, you take phosphate ion separately. Okay. In phosphate, phosphorus will be in +5 state. If you want, you can calculate. This is orthophosphorus acid. I explained so many times, no need to explain again. In orthophosphorus acid, phosphorus will be in +3 state. This is hypophosphorus acid. I have explained with structures in the previous questions. Here phosphorus will be in +1 state. So you need the highest oxidation number. That means third option. Here phosphorus will be in +5 state in phosphate. Which of the following reactions does not involve the change in oxidation state of the metal? Let us check this. Obviously third option, because we came across this one several times. So here oxidation number is changing, This is where the oxidation number is not changing, because in chromate and dichromate, the chromium oxidation state will be +6 only. Okay, yes. Average oxidation number of iodine, Ki3, K plus, I3 minus, so -1/3, this one. Next, yes, question number 73. What are the oxidation numbers of nitrogen in NH4 plus and NO3? See, NH4, NO3, ammonium nitrate, NH4, NO3. You can write them separately, and I have explained the oxidation number of nitrogen in ammonium ions and nitrate ion so many times. In ammonium ion, nitrogen will be in -3 state in ammonia and ammonium ion. You take NH3, you take NH4 plus in both Ammonia will be in -3 state. You calculate. Here, nitrogen will be in +5 state. +5 state. Okay? Yes. So with that, we completed this worksheet. Let's meet in the next video. Thank you.